Hello, welcome all. Today we shall see the manufacturing process of biodiesel. So first of all, in the manufacturing process, we have to see the feedstock or the raw material that is required for the manufacture of biodiesel. The first feedstock that we use is the soybean oil or recycled oil, or animal fats can be used. Vegetable oil as well as any other recycled oil can also be used as a raw material for the manufacturing process of biodiesel. So we have to choose this raw material depending upon their cost and their availability. So soybean oil, recycled oil, animal fats or vegetable fats or any other recycled oil can be chosen as a raw material for the manufacturing process of biodiesel. So here the raw material that you see is a oils or fats. So we can say that oil or fats are esters, triglycerides. Okay, they are the triglycerides, and these triglycerides is required for the manufacturing process of biodiesel. So raw material that contains triglycerides, okay, triglycerides is required for the manufacturing process of biodiesel. So what is the general process? So general process is what we have to do. We have to do the transesterification of triglycerides. Oil and fats are triglycerides. Okay, oil and fats are triglycerides. So this oil and fats as a raw material is subjected to the transesterification process. So what exactly is the transesterification process? So in the transesterification process, what we do, we subject or we put fats and oil, okay, fats and oil for the esterification process, okay, esterification process, and therefore the esters which were there, these esters again get converted into another type of ester. Okay, the esters, triglyceride itself is a ester, so this triglyceride is get converted into another type of crystal, another type of ester, what we call a process transesterification. Means esters are converted into another different esters. Okay, ester is made to react and get it converted into another ester. So what that reaction is called as transesterification reaction. So the triglyceride that we have, this triglyceride or fats and oil as a raw material which contains triglycerides is transesterified so as to obtain the ester which would be different to the what we have in the triglycerides. Therefore we call this as a transesterification reaction, and the product that the ester that is obtained, we call this is a biodiesel. Okay, this is a biodiesel. So this is a flow sheet. Okay, this is a flow sheet, and in this flow sheet you can see that the raw material, vegetable oil, okay, vegetable oil or any raw material, grease or fats, or you can say soybean oil or any recycled oil can be used as a raw material over here. Okay, so this raw material is transesterified. Okay, transesterified. So there is a choice for us. This raw material can be transesterified in two ways. Suppose first one is the acid catalyzed transesterification. So acid catalyzed transesterification is done on the raw material when the raw material contains more than 4% free fatty acids. Okay, free fatty acids are triglycerides. Okay, so more than 4% of free fatty acids are there in a raw material, then what we do, we transesterified. Okay, that is in presence of acid. Okay, in presence of acid, this is transesterified, or we can say that ester is get converted into another ester. That ester is a biodiesel. Okay, so the feedstock is pre-processed. That means any content of water that is present or any contaminant that is present in the raw material is separated or removed. Then the catalyst, sulfuric acid as a acid is dissolved in methanol, and then mixed with preheated oil. So oil is heated and this catalyst along with the methanol is then put in the preheated oil, that is the raw material. So mixture is heated, okay, the mixture is heated and stirred. So what happens, the triglycerides, that is free fatty acid, triglyceride get converted into biodiesel, that is another ester, okay, different ester to what that exists in triglyceride. So it is different ester than that of a triglyceride. So here you can see the chemical reaction. So this is a triglyceride, so in presence of ethanol or methanol or alcohol we can say, along with the acid, that is sulfuric acid, is mixed together, it is mixed together and heated so that trans-esterification reaction takes place, and separately what we get a 3 different ester, what we call this as a biodiesel or free fatty acid alkyl ester, okay, free fatty acid alkyl ester. Along with there is another byproduct that is produced is glycerol, okay. Glycerol is also a very important constituent for making as a raw material or a ingredient for cosmetics, okay, for cosmetics. So glycerol is mostly preferred as a raw material for cosmetics, okay, raw material for cosmetics. So this reaction in which the free fatty acid, okay, free fatty acid, whenever its content is more than 4% in any of the raw material, then it is trans-esterified in presence of what we say acid, and the content, or after trans-esterification what we get is the separate or fatty acid alkyl esters, and this fatty alkyl acid esters are nothing but the biodiesel along with some byproduct, what we call this as a glycerol. This glycerol is also used as a raw material for making the cosmetics, okay. So here you can see in the flow sheet methanol, or what you can say H2SO4 and alcohol, okay, H2SO4 and alcohol. This is treated with what we say any raw material, okay, any of the raw material, okay, any of the raw material like fats or oil, then this is trans-esterified, okay, this is trans-esterified. So this is trans-esterified, okay, this is then trans-esterified. So after trans-esterification reaction what we get is the biodiesel along with the crude glycerin or glycerol, okay, crude glycerin or biodiesel, okay. So this is the product that we get. So acid esterification is done when the fats or oil as a raw material contains more than 4% free fatty acid, okay. Next one is the base catalyzed trans-esterification. So the first one what we have seen is the acid catalyzed trans-esterification, and another process is there, base catalyzed trans-esterification reaction, in which if the feedstock, that is the raw material, okay, raw material contains less than 4% fatty acid, less than 4% fatty acid, then base catalyzed trans-esterification is done on it. So base catalyzed means in presence of base, okay, in presence of base may be KOH, NaOH, can be taken as a catalyst, and esterification or trans-esterification is done on it. So at the end again what we get is the ester as a product along with the glycerol. So this ester again is a what we say is a biodiesel. So there are two processes, acid catalyzed process as well as base catalyzed process. Acid catalyzed process is done when feedstock content more than 4% of free fatty acid, that is triglyceride, and base catalyzed trans-esterification is done when the feedstock contain less than 4% free fatty acids, okay. So all the raw material that we use, it must be pre-processed in order to remove the water or any contaminant present in it. This is the prior thing that we have to perform, okay. So in order to have in a purest form the raw material, okay, raw material, as the raw material should not have to contain any water or any contaminant, otherwise it could continue when the biodiesel is formed, okay. So this is thing. Moreover, here base catalyzed NaOH and KOH is used as a catalyst which is dissolved in methanol, and then mixed with preheated oil. Okay, as what we have done in acid catalyzed transesterification, the same procedure is adopted over here. Only the catalyst change is there. In the previous one, what we have used is acid. Here NaOH or KOH as a base is mixed with methanol or dissolved in methanol and then treated with preheated oil. So the product that we get is the biodiesel, okay, along with the glycerol. They are separated in two different layers. So here you can see methanol plus NaOH treated with vegetable oil, transesterification reaction takes place, and finally what we get is the crude glycerin plus or along with biodiesel. So this is what we expect. Biodiesel is expected one, along with the glycerol or glycerin is obtained. Now once the process has been over, that means the process through this process what we have obtained is the biodiesel. Okay, this biodiesel is a crude biodiesel. Moreover, the glycerol that we obtain is also a crude glycerol. Why? Because both are present in intimately mixed, and therefore we can say that these two have to be separated from one another. And that is why we here call this glycerol as crude glycerol and biodiesel as crude biodiesel. Moreover, this content, okay, this content so formed may also contain some amount of water, unreacted KOH or acid. So this ingredient also, or this content may also be present in this product formed, that is glycerol or biodiesel, and therefore it need to be separated. Okay, this need to be separated from unreacted one or water. So water, excessive water, acid and base, something, all this may have to be separated from this. So and finally this glycerol and biodiesel have to be separated from one another, and therefore eventually what we would get is the biodiesel in the purest form and glycerol in the purest form, because glycerol is required. Okay, glycerol is required as a raw material for cosmetic industry. Okay, and biodiesel is a fuel. It's a fuel, and this is so obtained from what we say biomass. Okay, or we can say that this is a green fuel. Okay, this is a green fuel. Vegetable oil, all those types of oil, where from we obtain? We obtain from the feedstock. Okay, feedstock. That feedstock is nothing but a biomass. Okay, this biomass can be converted into some kind of what we say oils. Okay, so and these oils can be a raw material for manufacture of biodiesel, and therefore we can say that eventually we can say that the feedstock is the raw material for manufacture of biodiesel. Okay, so what we have now obtained by both the process, the crude glycerol and along with the biodiesel. So these two need to be separated. Okay, so the first thing is what we have to perform, that methanol is also present, because we use methanol, or in methanol acid or base is dissolved and is made to react with the oil, preheated oil, and therefore initially what we have to separate the methanol. Okay, so first of all we will see the methanol recovery. Okay, methanol must be separated from biodiesel and glycerin or glycerol. Okay, and this methanol so separated can be used further. Okay, further or recycle back in the process. So here you can see the methanol which is recovered or separated from this one, from glycerol or biodiesel, is used or recycled and could be recycled and add along with the NaOH and again enter into the process. Okay, again enter the process, and therefore we can say that initially whatever the methanol is there present in the product, that have to be separated, what we call this as a methanol recovery, and this methanol is then recycled back. Okay, recycled back. Sometimes if excessive methanol is present in the product, that is in the glycerol along with the biodiesel, then this could reverse the reaction. Okay, methanol can reverse the reaction, the process could be reversed, and that is why it is necessary as long as the product is formed, the methanol should be recovered or methanol should be separated. Okay, and this methanol can be recycled back. Now next is the biodiesel refining. So once biodiesel is separated from glycerol, okay, so depending upon what we say phase separation. Okay, so if biodiesel is not soluble in glycerol, glycerol. So this can be separated on the basis of phases, okay, on the basis of what we say phase separation. They may be separated from one another. So this biodiesel is separated from glycerol, and this glycerol, okay, as well as biodiesel need to be refined, okay, need to be refined. That means the unwanted one or unwanted material or unwanted ingredient should have to be separated, okay. So while doing the biodiesel refining, excessive amount of alcohol as well as catalyst, if it had been produced by acid catalyst transesterification process or base catalyst transesterification process. So catalyst as acid or base have to be separated along with what we say soap, that is what we say glycerol, okay. Some amount of glycerol may be present in the biodiesel. So alcohol, catalyst and glycerol have to be separated from the biodiesel. So this is done, this process what we call this as a biodiesel refining. So furthermore, once biodiesel we have obtained, it need to be treated with washing, or it must be washed with water, clean water. You know that acid or bases or alcohol, excessive alcohol that is still in the biodiesel get soluble in the water, okay, get soluble in the water. Even glycerol is also get soluble in the water, and therefore it should be treated with water, clean water, so that all of this content which are soluble in water can be separated. And biodiesel is not at all soluble in water, and therefore these two get separated on the basis of what we say phases, okay. We can separate it on the basis of different phases that are get transformed when biodiesel is mixed with water or water is mixed with biodiesel, okay. So biodiesel becomes free from all these residues like alcohol, catalyst or any glycerol, okay. So finally what we get, the biodiesel as a colorless, odorless liquid, okay, colorless, odorless liquid, what we call this as a biodiesel. Or if required, a distillation process may be performed, okay. Distillation process is performed in order to separate any of the alcohol content still left or water that is remain as a residue. This biodiesel is subjected to the refining process through distillation. Then after the distillation what we get is the colorless, odorless biodiesel, okay. So this is what a biodiesel refining. So this is then dried and can be used. Moreover, glycerol is used as a raw material for the manufacture of cosmetic, and therefore it also need to be purified, okay. It also need to be purified. So glycerol is then neutralized, okay. It is then neutralized with acid, so that any extra base that is present in the glycerol could be neutralized. Moreover, if acid content is both there, then it could be neutralized with base, so that acid base reaction would generate water, and this water and alcohol, when they are removed from the glycerol, what we get is the 60 to 80% glycerol. That means what we have to perform in case if the glycerol is produced or biodiesel is produced in presence of acid catalyst transesterification reaction, then excessive amount of acid must have to be neutralized, okay. So this is done by adding or taking by making it to react with base, so that acid base reaction neutralizes one another and water is formed, okay. So, or in other way, if base catalyzed transesterification is done and excessive base is there, then it must be treated with acid so that it can be eliminated from the glycerol, okay. So ultimately or eventually at the end of the process, what we get is 60 to 80% crude glycerol, okay, crude glycerol. Moreover, many such step has to be performed, like in order to remove water, alcohol and water also remains with in the glycerol, as already discussed, that this also has to be separated, okay. This also has to be separated, water as well as alcohol, okay. And finally The remaining contaminant, including fats and oil, the unreacted fats and oil, okay, fats and oil also have to be separated from the glycerol. So what this is called as a glycerol refining. And once all of this content has been separated, that is water, alcohol, fats, unreacted fats or oil, or acid or base, this unwanted content from the glycerol can be separated, and eventually what we get is the glycerol, which is 90% pure, and this directly can be used as a raw material for making pharmaceuticals as well as cosmetics. Okay, cosmetics.